Hello everyone, I'm Xiao Gang. Okay, for this lesson we need some assets. You can directly migrate these assets from my project. That should work. Or you can find these assets from other sources. That's fine too. I previously suggested you just copy them from the project and use them. There shouldn't be any problem, okay? We find this item here. It should be here. We should create a new pickup for it, meaning something we can use to pick it up. After creating the pickup, we open this potential. Here we actually need to create several new assets. Then for these assets, we find this max code miscellaneous and data asset. Then find potential. So we should create two new assets. Okay, let's paste another copy. As for the name of the first asset, we'll call it potential health. The name of the second asset we'll call potential imala. Then let me check if this name has been changed. Okay, after the change is done, we need to sort out some assets. And this is our project here. So when sorting out assets, we actually have some lazy methods. We can directly paste these three assets in. We mainly just need these three textures. Okay, then over here, let's show it. Alright, then you will see these three textures here. If it's a bit more troublesome, it's that in pickup. Inside pickup, we need to add some model and dialog resources. So for this pickup, we will continue to give it a potential. Then we will also give an ANSYS folder. Okay, that's fine. Actually, we can, for example, here, you can do this here. I've demonstrated it to everyone. Okay, I'll take a shortcut here. I just dip these three brothers together. Then we go directly back here. We go back here again. We'll make it find a way. This one is quite troublesome. Then I'll just migrate it. This one is a bit troublesome. You need to pay attention to this one. These assets should have no external dependencies, otherwise it will be quite troublesome for you to handle. Let's just migrate it. Then we put it into our project. It should be this one, then content. Okay, this disappearance, don't worry about it. Wait a moment. It will appear after refreshing. Actually, right, it's just a small issue. Okay, so this asset already exists. Let's double click to open and check it. It should be fine too. Good. Then let's come back. So with such an asset, we need to do some configuration. Let's go back to our potential again. Then we'll configure them one by one. First, let's specify our ability as potential health. Then in its name, we call it health, although we don't need this field yet. We'll just leave these here. And for this image, we'll use this to potential health. We can actually write any numbers here. But don't just write anything for this man count. Okay, after writing this, we write the second one. The second one, this partition manner. Of course, you can integrate more complex logic. That is which asset or model it points to. All of this is perfectly fine. No problem at all. Yes, it's just that sometimes game designers really hate it. You have to match assets one by one. He really likes to use them. Excel and the like. Then you can have him generate dynamically based on Excel. That is also perfectly fine. There are many plugins in Unreal Engine. Because our detail can generally only use CSV or a TXT file. It's still not very convenient. Or use JSON and the like. That is also acceptable. Okay, once these two assets are defined after completion, let's go to our countum. Let's close everything on the right. Okay, inside pickup. Let's write something inside pickup. We definitely have something like a pickup base. Let's just, actually we should have a spawner here, meaning you need to spawn this object, but we won't write this spawner. We'll just give a pickup. And then give a base. Okay, then here, give it a pickup base. Let's open it. And as for this one, we'd better open its BV Practic. Yes, okay, after opening it. But it depends on your needs whether this thing is something you want to move or something like that. It's all possible. Then what should we do here? Let's add something to it. First of all, let's add a Sophia collision box to it. This added a sphere. It should be a collision box. Look, this is the ceiling detection box. Okay. Then we set it as a root component. Pay attention, this must be network synchronized. If it's not synchronized, problems will occur because we need to control the life and death of this thing on the server. So generally it needs to be synchronized. Okay. Next, we might need an ATM mesh, a static mesh. But depending on your needs, you can choose dynamic or static mesh. Here, we select the state meshes. SM potential. Okay, good. The reason it moves is due to the material, so we don't need to worry about it. We can add a light to it. Or all of these are possible. For example, I'll add a light to them. We can place this light underneath it. Okay. Then for this light, we can give it a color. For example, in our constructor, we get this light. But you must make sure the light is used properly, because lighting brings significant performance overhead, so everyone tends to use it sparingly. But it's still okay when we go inside. We promote this thing to a variable. We call it light color. By default, we give it a red one. Okay, then at this point, go to our event graph here. And we mainly handle this Sophia. For this mesh, we must turn it off. It should not have collision. Here, we set it to no collision. We only allow this Sophia to have collision. Okay, then for this, we have an event below called OnActorBeginOverlap. When it starts to overlap, we need to handle it. First, we need to convert the overlapping object into this, so that our character accumulation can work, because if it's not character accumulation, we cannot process the subsequent logic. But this kind of cast has a very high overhead. You can optimize it through some methods. Let's rename it. Next, we write a custom event and call it. Give it. This is equivalent to registering this thing. Okay, let's call this event. Okay, then in the give it event, first of all, we give a variable. This variable indicates whether it has been activated. Okay, then we give a bool. By default, it is not activated because something can generally only be triggered once. If you trigger it repeatedly, there will be a problem if it has not been activated, and now it encounters an activation situation. Then we turn off the collision. We don't need it after it has been activated. Then we set this activity to be configured. It has already been activated. Okay, next, we can play an animation for it. As for this animation, we also put it here. Let's put it here for now. We'll wait on the animation and fit it in later. We call it element collection, animation collection. We'll ignore the rest for now. Let's just call it like this. Okay, we'll leave that alone. Then after the animation collection is complete, we need to check if it is on the server. If it is on the server, we need to do some work. That is, we need to add it to our main task. Then here we get our character base. Then we get its inventory. Get inventory should be accessible. Just get this directly. Then here, we will write a blueprint function for everyone. That is our add inventory. After the addition is completed here, we will do we promote this thing to a variable. Okay. Then, for this thing, we will change its name. We call it item2add. Then compile it. You will see that here we can specify what assets or abilities to add. What is the quantity to add to it? So we won't write it here. Won't write it. Okay, now let's write something related to animation. Here, first, we take our item mesh, get this name, change it to item mesh. we get this. Then we get its order location and its current position. Then we add a position to it. Because this position might be relatively low, we want it to be in a slightly higher position. Then we promote this variable. Promote it to a variable. Promote this temporary child to a variable. We'll call it measure location. At this point, we want to use a timeline. We have a timeline. Everyone should have used a timeline before, right? Timeline. We'll create a timeline. At this moment, this timeline of ours, we double click it. Then we can enter. After entering, let's add a new one. A floating point value. Then set its time to 10 seconds. Faster. Then we add keyframes here. Add the keyframes. Then here we give it a 0.5, and here give it a 1. Then let's enlarge it a bit. At this point, we need to make this curve smarter. First, let's rename this curve. Let's call it peak up alpha. Looks like alpha is misspelled. Then we select this point. We make it R2. EC. This way, it has a read. Then OK. Then go back here. Then it will play. Then when it finishes playing, we make it destroy itself. Of course, for this destruction, we'll do it in the story. Okay, if we are in the story, we then destroy it. Then at this moment, during this process of continuous approximation, we obtain our ATM mesh. Then we set its relative, set its three-dimensional transform, which is equivalent to a three-dimensional transform. And at the same time, we also need to set its world position. You touch it! Set order location. Okay, pay attention. The first place, we are attaining its original size. Then this original size, we work on it. It adjusts based on this alpha value. This alpha value from 0 to 1. Do an interpolation. We make it smaller, so that's the idea. Then here, it's actually the same. We get the target position, and our current position, it should be our current. It should be this position. Then do a linear interpolation between the two, and the alpha for their interpolation. It's this alpha. Then we just move it to this position. This is the process of an animation curve. Basically, after this is done, at this point, we need to create its potential subclass. Let's first create one. We'll drop it in. Okay, here we'll give it a name. Rate. Simple enough. And here we'll give it a name called blue. Let's configure read first. We go into cast default. What we need to add is a health. We need to add 3 health points. We'll leave the rest alone. Then we go to this blue. For blue, we'll have it add mana, and we'll give it 2. Then we adjust the light color to blue. Okay, so we are done here. Here, we can change this material. It should be possible to change the material. We forgot to change this material. Here, let's replace this material with a blue. It should be available. This one was replaced incorrectly. We must replace it with the material we imported. Okay, this is a material instance now. Okay, now in the level, let's place 2 of these. Let's see if it works. Of course, this collision box, I think it's good. Personally, I think it's a bit small. We can make it bigger. This collision box is too small. Okay, as for the color, let's check it. It should be right. It seems we reversed the color. This color is blue. It is blue. Let's check again. Slow down. Its material should be modifying its material. We modified this material incorrectly. Let's change it back. We find the location of this material ball. It should be blue. This should be... Find this should be here. Okay? Okay, let's save it again. Then we find its parent class. This collision box is currently too small. The collision box of our parent class. Let's see if it should have a parameter. Let's change it to 80. Or change it to 120, a bit larger. Okay, now let's launch our client again. Let's take a look. You can see we have successfully added both the health potion and the mana potion. Now let's cast this. Then press Shift plus F1. And let's check. Okay, it seems this skill didn't take effect successfully, right? Let's check the reason here. At least our current attempt can be completed smoothly. Okay,